So we know that sine is y over r.
How do you know what r is from that chart, though?
Good question. R is always going to be positive because r is the hypotenuse. I'm glad that you said that. Since it is the radius or hypotenuse. Okay, so first quadrant, your y-coordinate is positive. R is always positive. So what's a positive over a positive?
Positive.
Nice. So in the first quadrant, sine will be positive. In the second quadrant, are the y's positive or negative? Positive. So will sine be positive or negative?
Positive.
Positive. Good.
I don't get that.
Thank you for speaking up. So what we're doing is figuring out in what quadrants each of the trig functions is positive, or in which quadrants is it negative.
But how do you know which one is like the opposite or the adjacent?
So this is why I had you use this diagram to start with. The y is the opposite, the x is the adjacent, and the r is the hypotenuse. Okay? Are you still not understanding?
No, I get it.
Okay. Don't hesitate to ask if you have questions. Quadrant 3, is y positive or negative? Negative. So will sine be positive or negative? Negative. Yep. Remember, r is always positive. Fourth quad, take a guess. It is negative because the y-coordinates are negative. Any questions so far? Let's do cosine next. We know it's x over r. And now I'll call on random people. Melanie, first quadrant. Cosine, positive or negative? What do you think?
Positive.
And why? Thank you for your honesty. So tell me, in quadrant 1, are the x's positive or negative?
Positive.
Positive.
Yeah.
Is r positive or negative?
Positive.
It's always positive.
Yeah.
So what's a positive divided by a positive? Positive. There's a reason. Skylar,
Yeah.
cosine, positive or negative in quad 2?
Quad 2, x is negative. So I'm going to go with negative.
Very good. In quadrant 2, the x's are negative, so you have a negative divided by a positive. That is a negative. You're just taking ratios of positive or negative numbers. Okay? Brooke, quad 3, cosine, positive or negative?
Negative.
Negative. That's because you have a negative over a positive, which is a negative. Good. Jordan, cosine, quad 4, positive or negative? It's positive because the x-coordinate is positive in the fourth quadrant. Any questions on the cosine row? Alexandra, let's do tangent.
In the bathroom.
Well, get her on the phone. Jeez. Excuses. Jake, tangent, first quadrant, positive or negative? Very good.
Can we do the x's too or no?
What do you mean?
Because like the other ones were r, so
R is always positive.
yeah, but x, it's y over x, not y over r.
So
Correct.
Positive over positive.
So would you do like for those we all have either positive or negative, but for the tangent are we gonna have two answers? since it's y and x.
No, you'll have one answer for each quadrant. But it's like Jake said. In the first quadrant, your y's are positive and your x's are positive.
Yeah.
So the ratio of a positive to a positive is a positive, right?
Yeah.
So tangent will be positive in the first quadrant.
Okay.
Capiche? Scott, quad 2, tangent, what do you think?
Negative.
Negative. Agreed. Because you have a positive over a negative, and that's a negative. Vicky, tangent, quad 3.
Negative.
This is actually going to be positive because you have a negative divided by a negative, which is a positive. Ashley, tangent, quad 4, what do you think?
Negative.
It is going to be negative. Yep, because you have a negative divided by a positive. Good. And Brooke, let's do cosecant. Yeah, first quad, yeah, positive. And Shirley, quad 2 for cosecant? Positive. And Anthony, cosecant, quad 3?
Positive.
It's actually going to be negative.
Yeah.
Yep, because the y coordinate is negative. Alec, quad 4?
Negative.
Negative. Yep, again, because the y coordinate is negative. Good. Next, secant, we know is r over x. Scott, first quadrant.
Secant, first quadrant is positive.
Very good. And Melanie, second quadrant, secant.
Positive. Negative. Negative.
So what thought process do you think you would go through?
I don't know, I was thinking about R and how it's always positive.
Very good. That is definitely a start.
Yeah. So it's positive.
Then think about x. In quad 2, is x positive or negative?
Oh, it's negative.
It's negative. So you have a you have a positive divided by a negative,
Oh, negative.
which is a negative. Okay. Sam, secant, quad 3.
Negative.
It is negative. Good. And Noi, secant, quadrant 4. Positive or negative?
Wait, why is the other one negative?
Positive. Why is this one negative?
Yeah.
Because
Negative and a negative is positive.
r is always positive, by definition.
Yeah.
X in the third quadrant is negative. Right?
Oh. Okay, yeah.
Okay. Last one. Cot. Cotangent. James, first quadrant.
Positive.
Positive. Good. Scott, second quadrant.
Negative.
Negative. Good. Liam, third quadrant.
Positive.
Positive. Good. Brooke, fourth quadrant.
Negative.
Negative. Notice connections. Notice that the sine row is the same as cosecant. Cosine is same as secant. And obviously tangent is the same thing as cotangent.
Is Y always negative?
Y is not always negative. Y is only negative in the third and fourth quadrant. Okay? R is always positive. There's a few reasons for that. One, it's a hypotenuse, it's a radius, but that might not be good enough for you. Another answer could be that in the Cartesian coordinate plane, we have negatives for x and y. But when you find what r would be, it's always going to be positive. You might ask why. Well, if you try to find r, you got the square root of x squared plus y squared. That's just the distance formula. And that's nothing fancy, like Iggy Azalea. I know, I'm hip, I know. This, if you're trying to find this, you can just use the distance between 0, 0 and x, y. And when you do that, plug that into the distance formula, you get this. And when you take the square root of a number, it's not going to be negative. Okay, so those are the best answers I can give you as to why r is always going to be positive. Good. Any questions on that? Now, many trig students learn the mnemonic device, all students take calculus. I did. So I'll share that with you now. In the first quadrant, notice that all of the trig functions are positive, yeah? So we put an A there. In the second quadrant, only sine and its reciprocal are positive. So that's the student's part in the mnemonic device. In the third quadrant, tangent and its reciprocal are positive. And in the fourth quadrant, cosine and its reciprocal are positive. Okay? All pos, sine and its reciprocal are positive, tangent and its reciprocal are positive, cosine and its reciprocal are positive. Okay? If you don't like all students take calculus, come up with another one. I've heard a smart trig class. How cute. However, my personal favorite is one that doesn't make a lot of sense. It's a fun story, I think. So, in the legendary Mr. Murray's class, he's no longer with us, there was a student who wasn't very attentive, wasn't very participatory, wasn't the top student. So Mr. Murray did not have very high expectations for this student. And Murray told the class about all students take calculus, and then he probably said, if you want to come up with something that you remember better, go ahead and do so. So like 2 weeks later, Murray's working on some other topic. This kid, who rarely raises his hand and says, Mr. Murray, I got one. Murray doesn't understand what he's got. Again, this is 2 weeks later. And the kid goes, I got something for that ASTC thing. All right, let's hear it. Are you ready for this? All Santa Claus. Not just a Santa Claus. All Santa Claus. I also particularly like how he split up the word Santa. Okay? Anyway, it's my personal favorite, but you find what works for you. Okay? Any questions on that? ASTC. Word. Okay, so here's the deal. The reference angle is an angle inside a right triangle, as you can see here. We'll use an apostrophe next to theta to denote it, often said theta prime. You need to know that it's always positive, so I would underline that. You'll never have a negative reference angle. You need to know that it's always acute, so it's never going to be greater than 90 degrees. The other key thing I would say is that it's always with respect to the x-axis, never the y. That's a common mistake I see every year teaching this course. When I ask students to find the reference angle, sometimes they will refer it to the y-axis. It's never. It's always to the x. And it has to do with the fact that when you draw the right triangle here, you draw the altitude to the x-axis, never to the y. And I can explain that later maybe, but for now I'll just leave it as is. So let me explain this bow tie. When you explore trig, you find out that the sine of 30 degrees is the same thing as the sine of 150 degrees. You can prove that to yourself with a calculator. And you may be wondering why. Let me explain. It's all about right triangles. Okay, so here's 30 degrees drawn in standard position. It also creates a 30, 60, 90 triangle. If I make this side 1, tell me what this side is, please. Root 3. And then this side. 2. Okay. So we know by now that sine is opposite over hypotenuse. 1 over 2. Let's now go to 150 degrees. When you draw that in standard position, you start from the positive x-axis and you go counterclockwise. It still has to do with right triangles. We're still in right triangle trig land. Later on, we'll level up. Okay. From here to here is how many degrees? 180. What's 180 minus 150? 30. So you have, again, a 30, 60, 90 triangle. I'll make this 1, this root 3, this 2. So I want somebody to tell me what are the coordinates of this point here. I'll give you a hint.
3, 1.
Try one more time, Brooke.
Negative root 3, 1.
Nice. So the x comes from how far it is from the origin to this point here. That's directly below this point of interest. Okay? So this is going to have an x coordinate of negative root 3. Does that make sense?
Yes.
Because it's root 3 units from the origin to that point. So the x coordinate is negative root 3. The y coordinate, thank you, is going to come from the height of the right triangle, which is 1. We now know that sine is y over r. Our y coordinate, thanks to Brooke, is 1. The radius or the hypotenuse is 2. Okay, so sine of 150 degrees is the same thing as the sine of 30 degrees, 1/2. Okay? So my recommendation to you is maintain your understanding of the right triangle. Draw the full angle, drop an altitude, or raise an altitude up, draw the right triangle, find the reference angle. It's the one that's between the terminal side and the x-axis. It's always acute, it's always positive. And use that to determine what the value is of the trig function for the non-acute angle. Okay? So let's go back to this and we can generalize. If our angle's in the first quadrant, the reference angle is going to be the angle itself. So I'll just write equals theta.
For all the RAs equal theta.
In the first quadrant. Yeah. So if your angle is 50 degrees, what's the reference angle? 50 degrees. Okay. Let's go now to the second quadrant. I'll ask a volunteer. What do you think the reference angle is if your angle is in the second quadrant? Good guess. Well, it's always theta prime. That's the symbol that we're going to use for the reference angle. So try again. I'll give you a hint. Think back to this example.
Theta?
It's not just theta.
Negative theta prime.
Not negative theta prime.
Negative theta.
Not negative theta. That was stated already.
Positive theta prime.
No.
Positive theta.
You're not getting anywhere closer to the answer. So I'll give you some guidance. Look at 150.
Okay.
That's your main angle. Compare it to 30. That's your reference angle. What's the relationship?
5.
They're complementary.
Supplementary.
They're supplementary. Okay?
So what about the picture? Is it supplementary in the picture?
Well, this reference angle plus this angle here are supplementary, yeah.
So I think it's just confusing because there's no numbers and it's not on top of.
I understand. And that abstraction is something that I would say blocks a lot of people from progressing in math. Okay, so can you give me an expression for the reference angle in terms of theta for the second quadrant?
2.
It's not going to be 2 theta.
180 minus theta.
Nice. 180 minus theta. So if your angle is 100 degrees, what's your reference angle?
180 minus
180 minus 100, which is 80. Good. Third quad. What do you think? How do you think you'll find the reference angle if it's in the third quadrant? 210? We don't know it's going to be 210. All we are given is an angle theta, and we want to find the reference angle from it.
Negative theta.
Not negative theta. So I'll guide you some. You're trying to find the acute angle in here. And the angle that you're given, the one that's in standard position, is this full swing. That's theta. So what do you think the reference angle is? It's not just theta.
1/3
1/3?
of theta.
No.